Welcome to InventorCAM Professor. I'm Sydney, your InventorCAM Professor, and in this session we'll be learning how to create coordinate systems in turning and in mill turn. If we take a look at this part, you can see that this part, in order to machine it, it has to be done both in turning and in milling. For this case, we'll use the mill turn machine. Now, some notes that should be noted before we start machining. You'll note that I've created some sketches around the part. What we have here is actually three different sketches. My first sketch being this line here, that if I take a look at it, this will be representing my boundary for the part itself. My next sketch is this area over here. This will be representing my chuck, my spindle for the part. And my last sketch, in this particular case, this box over here, will represent my back spindle for the part. These are essential for creating your coordinate systems in turning and in mill turning for when you're turning a part. Now we'll start off by going into Inventor and creating a new mill turn part and storing it in the designated area where I want it to be stored. Now you'll note that the CNC controller in this particular case that I'll be using will be an Integrex E410H, which is a mill turn machine. It should also be noted that on a mill turn machine doesn't mean you have to do parts that are only for mill turn. You can do parts that are just milling. You can do parts that are just for turning as well. We'll start off by creating our coordinate system. Now when I create my coordinate system, what's important to note is that I am working on center of revolution face. And in this particular case, I like to choose this circle here. And I'd like to have my axis actually going in the opposite direction. Now simply change it to change to opposite. And you'll note that change to the opposite direction. And now I'll simply click on finish. Now, since this is a mill turn machine, I get the same options that I do over here as in a milling part. This is because this particular home position I can use for milling as well as for turning. Now, if I want to create another home position, I simply right click, add another home position, and let's say I'll choose this surface over here, and I now have a new home position for my milling of these flat areas, and I can continue on as we go along. I'll simply click on finish, and now I'm ready to create my material boundary. Now when I create my material boundary, there are several ways I can do this. Now let me just take my XZ view over here, and you'll see that this is the orientation of my part, where I have my main spindle and where I have my back spindle. My 2D boundary is one of the options I can use for creating my material boundary. If I choose that, I simply click on define, define chain, and simply click on that one line that I've created and say finish. The moment I've done that, you'll note that my material is now dropped down to the exact center of the part itself, and now I have complete material boundary around the part. That's one way of creating my material boundary. One of the other ways that we can create material boundary around the part is using the option of cylinder. If I choose cylinder, all I have to do is simply click on define, click on the part itself, and you'll note that material is about to be created around the part, where my left -Z, which is this side over here, I can control the excess material on that side, and I'll have it say at 10 millimeters. And as you can see now, it's 10 millimeters away from here. My right side is set at a 0.5 millimeter. Let's just set it at 1 millimeter for now. And my external is set for 2 millimeters. Now you'll note that even though my material over here is set for 2 millimeters, that is correct. Now, the reason why this is actually correct, this material boundary rather than this material boundary in this case, even though this doesn't look like 2 millimeters away, is for a very simple reason. If I start turning the part around, you'll note that this is a flat area, and the part actually has to turn around here, which is actually bigger or higher up than this area. So this is automatically taken into account when I create my boundary using the cylinder method. I'll simply say finish, and I'll say OK. Now, as for our main spindle and back spindle and our target model, we'll be discussing this in the next part of creating coordinate systems for turning and mill turn. Thank you for joining us on InventorCAM Professor. Take care and have a nice day.